Today we're going to look at mole fractions and partial pressures. So remember, a mole fraction is looking at a mixed gas and the fraction that that gas has in the container. And it is proportional to the partial pressure. So for example, if you have 20% oxygen, then 20% of the pressure is due to oxygen. So the partial pressure would be 20% of whatever your total pressure is. So we're going to talk about some calculations that we would do with this. So let's do one example. 12.5 liters of a scuba diving tank has a heliox mixture of 24.2 grams of helium and 4.32 grams of O2 at 298 Kelvin. Now, oftentimes they'll ask questions like, calculate the mole fraction. Okay. They might also ask to calculate the partial pressure and also the total pressure. Now, in this case, we couldn't do the partial pressure if we didn't know the total pressure, because we also are figuring out the mole fraction. So we'll use the mole fraction, apply it to the total pressure, and then we can find the partial pressure. So let's get started. How do we solve a problem like this? Now, the first thing is we need information about our individual gases. So here we have the mass of helium and the mass of oxygen. So to get the mole fraction, we probably need moles. So let's convert both of these to moles. So I'm going to do 24.2 grams of helium, and I'm going to convert that. Okay, 4 grams of helium are in 1 mole of helium. Multiply that on the calculator. Okay, and this is 4.00, sorry, there. So we're going to end up with 6.05 moles of He. And if we do the same thing with our oxygen, 4.32 grams of oxygen and 32.0 grams of O2 are in 1 mole of O2. And we're going to divide these out, and we're going to get 0.135 moles of O2. This has 3 sig figs, and this has 3 sig figs. Okay? So now we know the moles of helium and the moles of oxygen. Now to find the mole fraction, we of course need part over the whole. So we need to know how many total moles. Well, we can easily do that by just adding. Okay? So total moles is equal to moles of He plus moles of O2. So moles of helium, 6.05 moles, plus moles of oxygen from up here, 0.135 moles. Okay? And we're going to add these together and get 6.185. Now when we add, remember we go to the smallest decimal place. So there's only 2 decimal places here, so we have to report our answer with just 2 decimal places. So we're going to round up with that 1.85 or 0.185 to 6.19 moles total. Okay? So our tank basically has 6.19 moles of gas in it. And we know that of that 6.19, 6.05 is helium. So to find the mole fraction, we basically take part over the whole. So we're going to do 6.05 moles of helium divided by 6.19 moles total. Okay? And that is equal to 0.977, which is basically saying 97.7%. We're going to leave it in the fraction mode. Okay? And now we're going to do the same thing for oxygen. So X represents mole fraction. The mole fraction of oxygen is again part over the whole. So 0.135 moles of oxygen compared to the total moles, 6.19. And that is going to equal 0.0218. So that's our mole fraction for helium and for oxygen. Okay? Now, we're going to use these later to apply that to the total pressure. If we know the total pressure, then we can multiply the total pressure by the mole fraction, and that will give us the partial pressure of that substance. But before we do that, so before we can come over here and calculate the partial pressure, we need to know what the total pressure is. Okay? So how do we find the total pressure of a gas? Well, we need some information. We're going to hope to use the ideal gas law, PV equals nRT.